So if this plasma that is really hot touches the antenna will melt.
To keep the plasma from touching the antenna, coils of magnets generate magnetic fields that wrap around the plasma and hold it in place. But extra heat still gets in the system, so the engineers are designing a protective ceramic sleeve to fit into the rocket. They call it a thermal jacket. Here they test how the heat behaves inside the rocket. The design of the thermal jacket is a work in progress. For Spectrum Online, I'm Sandra Upson.
Y ahora, el video que sigue más o menos casi que para cerrar el seminario, vamos a ver el video. Es un video que salió en National Geographic en Estados Unidos hace como 4 meses. Y después de ese video vamos a abrir un periodo de preguntas, si quieren, sobre el seminario en general o sobre las últimas 2 charlas que me dio contar.
How fast would we need to go if we wanted to send astronauts to Mars?
It's possible to get to Mars with a chemical-only approach, but it is not very practical.
It's not practical because it takes so much fuel just to get us up into space.
The analogy is the analogy of a car. When you get going in a car, you start in first gear. You need a low gear to get going. And that's what the chemical rocket brings to you.
First gear in the space shuttle takes it from 0 to 17,500 miles an hour in 8.5 minutes flat. On its climb through the atmosphere, those boosters on the side are burning 10 tons of fuel a second.
It's that kind of power that's needed to accelerate the space shuttle to 17,500 miles per hour very quickly. Within 2 minutes, all of the energy is released from the solid rocket boosters, and then they're thrown away, which is very similar to a first gear in a transmission of a car. The space shuttle main engines are then releasing, for another 6 minutes, release all the energy that's stored in the hydrogen and oxygen and propellant that's in the external tank. And so all of the propellant that's on the space shuttle is used up within 8 minutes.
And when the engines finally shut off, the shuttles consume nearly 1,500 tons of fuel.
Once you get to Earth orbit, you achieve orbital velocity of about 17,500 miles per hour, and then there's no more propulsion needed to stay in low Earth orbit. If you want to leave low Earth orbit, go into another planet, another more efficient use of the propellant is needed, which would be similar to third, fourth, fifth gear in your transmission.
And those who know space think it's time we take exploration into overdrive. And this former astronaut is ready to do just that. No one's been to space more than former astronaut Franklin Chang Diaz. He's logged more than 1,600 hours on his 7 flights aboard the space shuttle.
If you want to go to Mars, it will take you today about 8 months with a chemical rocket. Such a mission would be highly dangerous.
Dangerous because once beyond the Earth's protected magnetic field, the astronauts will be bombarded with deadly high-energy radiation.
In space, you need to give astronauts a fighting chance.
And for Chang Diaz, that fighting chance means speed. Lots of it. Chang Diaz is working on a new engine that could hurtle us through space at hundreds of thousands of miles an hour. It's called the magnetoplasma rocket.
Any rocket works on the principle of action and reaction. You shoot material at one end, you get pushed in the other direction by the action of the material medium.
Diaz's rocket bundles superheated plasma through magnets to produce thrust. And thrust means speed.
What makes it go very fast is because it's so hot. The particles inside a gas or plasma, in our case, are moving very fast. The
aligns these particles so that their movement is all going in the same direction. And that gives you the rock that you want.
Because the plasma is so hot, the atoms are moving at tremendous speed. The magnets in the engine align those speeding atoms and shoot them out to create thrust. So much thrust that with the magnetoplasma rocket, Chang Diaz thinks we can make trips to planets like Mars routine.
With this technology, we could get to Mars as fast as 39 days.
But for now, the magnetoplasma rocket remains in development. Chang Diaz hopes to have it ready for testing in space by 2011.
Our first test will be done on the International Space Station. Things will happen very quickly after that. I think that person that is going to walk on Mars is already alive somewhere. Hopefully it's here in our team.
Pasamos ahora al periodo de preguntas.
Bueno, me gustaría en primer lugar hacer un comentario a todo el escenario. En primer lugar, agradecer a Ronald, a Jorge, a Juan Ignacio, a Diana, el que nos hayan dado este seminario tan completo y tan interesante. Desde luego lo que hizo Franklin Chan al traer este laboratorio a Costa Rica fue abrir una gran puerta para que muchos estudiantes costarricenses se quiten esa venda de los ojos, ¿no? Y se den cuenta que como país podemos hacer grandes cosas, porque el pensar en innovar, en hacer cosas nuevas, cosas distintas que no se han hecho en otro lado, no está en el país en el que uno vive, sino está en la forma como uno piensa. Y